All right, I'm going to explain the two-way ANOVA, factorial ANOVA, by going over the one-way ANOVA first. Okay, so a one-way ANOVA means you got one IV, and it's a grouping IV, categorical or nominal, and you got one DV, one and only one DV. It's scale, continuous, score, etc., etc. So in this example, we're going to make our IV a profession. We're going to call it profession. The DV is going to be their annual salary. So we want to see if there's going to be a significant difference in the DV, that's the variance of the DV, by profession. So our three professions are dentist, teacher, and cop. So we grab a bunch from each and get their annual salaries. These are their annual salaries. So what the ANOVA is going to do is going to compare the means of these groups to see if there's a significant difference. And you could just gauge it right now. Yeah, this one is much higher than the other two. But if you're going to do this by hand, what you're going to do is you're going to calculate the between group variance, right? That's the good variance that you can explain. The reason that the variance is so different between the dentist and teachers and cops is because they all make different amounts of money. That's good variance. Within group variance is bad variance. So that's the natural occurring variance in each set of data. That's variance you cannot explain. So when you divide the explainable variance by the unexplainable variance, you get what we call your F ratio. So I'm going to go ahead and run this in SPSS. Hold on. In variable view, I'm going to click on that. I'm going to name that profession. Okay, it's going to be numeric. Don't care about width. There's no decimals in there. I'm not going to put them in there. Labels, I'm just going to leave it blank. It will use the name profession. Values, okay. So values, since it's a categorical variable, you need to represent each category with a number. So one was dentist. Add. Two was, what, teacher? Add. And then three was police officer. Add. Okay, we got our three different levels of the IV. And I believe we need to change it to a categorical variable. I'm sorry, yeah, nominal. Boom. Our second variable is going to be our DV, and this is just going to be salary. And again, it's going to be numeric, decimals, since we're not using any decimals. Sorry about that. And no values, but we do have to change it into a scale number. All right, so now we're good to go. Now we just have to enter the data. So professions, we have 8 dentists. That means I need 8 ones. 8 twos. And 8 threes, right? And I'm just going to double check, make sure there are 8 in each group. And yes, there are. Okay, so back to SPSS. And the salaries, I'm going to go ahead and type them in. So I'm just going to pause it while I type these values in. Please hold. So their salaries have been entered. Just double check real quick. So you got 8 ones, 8 twos, 8 threes. Everybody's got a number good. Boom. So now we're ready to go. First thing I'm going to do is real quick, I'm going to check to see if the DV is in fact normal. I don't care about that one. Plots, I do care. So I'm going to look at the histogram and the Kolmogorov-Smirnov test. Don't care about options. Click OK. Here's my output. And so I got 24 people in the group. Nobody's missing. There's their mean, 66. And normality, it looks like normality was violated. Okay, so it's just barely under 0.05, but that's still enough to call it unnormal. And you look at the data, yeah, this thing. So the data's not normal. So we're going to press on anyway, because I'm just trying to show you the big stuff. Okay, so then we would run our ANOVA. We're going to go to Analyze. And there's many ways to do this. Analyze. We could go to this one-way ANOVA down here. from comparing means, but it's better if we go through general linear model because that's what's coming up next. So go through general linear model, univariate. Your DV is your salary. Your fixed factor is your professions. And model don't care. Contrast don't care. Plots, meh, I don't care about that at this time. Post hoc, there are 3 groups. That means we can run a post hoc test on it, right? You have to have 3 or more groups before you can run a post hoc, and we're going to do the Tukey test. And save, nothing here. Options, yeah, we're going to check descriptives. We want effect size, power, and the homogeneity variance test. Click continue, click OK. And there's how many in each group. There's their means. There's Levine's test, and it looked like we violated the assumption of homogeneity variances too. So you would not use an Anova in this case. You would use its twin. I believe it's called the Wilcoxon's test. There's other ones, Wilcoxon and Kruskal-Wallis, I believe, but we'll have to look that up. But let's look at our F score. Here's our F score, and it's huge. It's 97, so we do have a significant difference. Our eta squared is, it's huge too. So we got a huge effect size. We got significance. So back to our model there. Hold on. So our F value is 97. Rule of thumb is if your F ratio is greater than like 3 or 4, it depends on sample size and other things. But usually if your F is greater than 3 or 4, you're going to have a significant difference. So we have a significant difference between the IV profession. Okay, now we're going to go and add a second IV. We're going to go ahead and call it gender. Hold on a second. Adding gender, bam. Okay, so we got females are the top half, males are the bottom half. So you look, this has changed now. This is no longer a one-way ANOVA, it's a two-way ANOVA. Or we can also call it a factorial ANOVA. Factorial ANOVA just means that you have more than one grouping IV. Okay, but now look at these are what we call marginal means. So this 63 is the average of all of these numbers lumped together, and this average is 70 is for the males. Okay, so if you're just looking at what we call the main effect of an IV, you simply compare the marginal means of that IV. So if we just want to see if there's a difference between the salaries in gender, we would simply look at these marginal means. If we wanted to strictly look at the difference between the profession salaries, we would look at these marginal means down here. Okay. So here comes in a nutshell. If there is a significant difference in profession, which we already know, we would say that there is a main effect of the profession IV. All that means is main effect means that there's a significant F if you strictly ran a one-way ANOVA with this single IV. If going this way, for gender, there would be a main effect of gender, you would simply use a t-test. Okay, but the word main effect means that, yes, there's a significant difference between the levels of that specific IV. So let's switch over to SPSS, and we're going to add a new variable. We're going to call it gender. And no decimals. And it's going to be a categorical. So we'll go ahead and make 1 females and 2 males. Better spell it right. Add 2 will be the boys. And okay, let's go back and look at our data real quick. So it looks like, okay, going down, we're going to have 4 1s, 4 2s, 4 1s, 4 2s, 4 1s, 4 2s. Okay, so hold on. Back to data view. So 4 1s, 4 2s, 1, 2, 3, 4. Okay, hold on while I punch that in. Done. Looks good to me. Okay. So we're going to see if there's a significant difference between professions, which we already know there is. Now we're going to see if there's a significant difference between gender. right? We're checking for main effects of profession, main effects for gender. And we're going to go to Analyze, General Linear Model, Univariate. Now we're going to kick in gender. We should probably fix gender first. Hold on. So gender is a nominal. And believe it or not, SPSS knows if you don't change it, SPSS is usually going to identify the right variable for you anyway. So let's go back, Analyze, General Linear Model, Univariate. And we're going to kick gender into our fixed factor. Factor means IV from now on. Don't need modeled contrast. No plots. And we don't need plots at this point in time. Post hocs. Yeah, okay. Gender, since there's only 2 levels, you won't be able to run a post hoc. But profession's got 3, and I think we forgot to look at it last time. But okay, so save options. And again, we're getting the overall. So what this is going to look for is to see if there's a main effect of profession, main effect of gender, and interaction between the 2 IVs. So here's the female dentist, female teachers, etc., etc. You can see their means all the way across. Levine's test, interesting enough. When we split it up like this, it did not violate the assumption of homogeneity variance. That's kind of interesting. All right, so here we go. So for profession, right there, okay, we know there's a significant difference between profession already. Gender, okay, there is a significant difference of gender. So there is a main effect of profession, there is a main effect of gender, but here comes the money. Bam, the interaction by that little star, that little asterisk between the 2 IVs. It shows that there is a significant interaction. Therefore, if you have a significant interaction, you would look at what we call the simple effects. So a simple effect is looking at strictly one level of one IV across all the different levels of the different IV. Example, a simple effect would strictly be looking at the female scores. Okay. Another simple effect would simply be comparing the male dentist, male teachers, male cops scores. That's a simple effect. Another simple effect is you can strictly look at the cops. Going down this way, you can compare female cops to male cops. That is a simple effect. Okay? Important, if you have a significant interaction, you really don't care about the main effects of the IVs because they're misleading. What this is saying is that there's an interaction between one level of one IV and one of the other levels of the other IV in such a way that that intersection of levels is causing the DV to be much greater or much lower than the rest of the grouping there. That's what this is. So again, when you have more than one grouping IV, it's called a factorial ANOVA. And you have the main effect of the first IV, main effect of the second IV, and interaction. That's what your ANOVA table is going to check for. That's what SPSS checks for. And again, last time, if there is a significant interaction, do not look at the main effects of the IV. You're going to look at the different simple effects. And the simple effects means you're going to run either a one-way ANOVA if you got 3 groups, or you're going to run a t-test if you got 2 groups. I'm going to show you how to do that in SPSS real quick. So I'm going to run a simple effect just for females on the professions. We're going to split a file. Hold on a second. Okay, you're going to go to data. I'm going to have to drag this up a little bit. Hold on. All right, we're from the data. See this split file way down here? You're going to click on that. We're going to split the profession. No, let's do them across gender. Okay, we're going to compare groups based on groups. So what we're going to do is we're going to get a male ANOVA and then a female ANOVA. Okay. And it reran. We got to rerun the ANOVA. We're going to do analyze general linear model. Everything should be preset as it is. So let me show you what the output looks like when you split a file. So there it is right there. So we have a female. This is a simple effect. So according to this, there was a significant difference in professions by females, and there was also a significant effect between the male salaries. Okay, so let's split it the other way. But before you do that, whenever you split a file, you have to physically go back and unsplit it. So back to data, and I got to raise this way up here so you guys can see it. You got to go back and unsplit your file. Okay, click that out, get it out of there. Now we're going to go by profession, and we should get 1, 2, 3 little t-tests. So again, we're going to go back to analyze, and we're going to just general linear model univariate, and it splits it up really nice for us. So, right, and here's the descriptive statistics, and there's Levine's, and so here's the dentist. So, right, the significant difference, there is no significant difference between the males and females for dentists. There is no significant difference for the teachers. There is a significant difference for the male and female cops, though. Interesting. So that's how you run simple effects in SPSS, and that's it in a nutshell. Again, if there's significant interaction, you really don't care if there's a significant F or a main effect of these IVs individually. But that's it. MGZ.